Okay, so here is problem 3 from test 1. A small glass ball here is rubbed all over with a small silk cloth and acquires a charge of positive 5 nanocoulombs. The silk cloth, which is here, and the glass ball are placed 30 centimeters apart. And yeah, so at the location marked X, you're supposed to draw and label 2 arrows representing the electric field due to the silk cloth and the electric field due to the glass ball. And the relative lengths of these arrows should be correct. So if the glass ball acquires a charge of plus 5 nanocoulombs, that means it's going to have a positive charge, and I'm going to represent that by 4 arrows, or 4 little pluses right here. So if the silk cloth caused this charge, it's going to have a corresponding negative charge, so it's going to have 4 little minus signs around it to represent that. So the arrow, the field due to the ball, because it's positive, it's going to be away from the ball. So here's E ball, right here with that. And then here, because this is negative, it's going to have a field going towards it. So here is E cloth. Here are those 2 arrows. And then, are you supposed to draw the net? Okay, 2 arrows, right. Okay, so that's part A. Okay, so then in part B, we have the same setup basically. So you have your negatively charged cloth here. I'll circle them in blue because that's nice. And I'll circle the positive charges in red, just to make it a little more clear. Okay, so you have your positively charged glass ball and your negatively charged silk cloth. And you have a positively charged metal block. So this is a conducting sphere, and by our conventions we draw only the charges, and it's going to be polar, or the charges are going to only be on the surface, but they're going to be more on the side closer to the negative thing. So kind of like that. And we're not going to have like virtually none on that side, but for this drawing. Okay, so then we're asked in the next part, in part C, to draw the electric field due to the cloth, which will still be in this direction. Okay, so E cloth. Okay, and then the ball will still be the same. So here's E ball. Like adding the sphere, or adding the conducting block won't change the field. Okay, and then the metal, because of these plus charges, these positive charges right here, it's going to create a field going away from the positive. So here's the field due to the sphere on the inside. And since the sphere is in equilibrium, it's going to have to be counter to the 2 field contributions going this way, because the field inside of the sphere is, the net field is 0 inside the sphere. So there's no arrow representing the E net, because E net equals 0, because inside a conductor at equilibrium. Okay, so then the next part, the metal block is taken away, and now we're given a plastic block. So each little atom inside the plastic block is going to form a induced dipole. So this is still negative, this is still positive. It's really, yeah. Okay. And then we're going to have a dipole, so the positive is going to be on this side, the negative is going to be here. Okay, and this one's going to be a little smaller because it's in the center. So it's going to be a smaller little dipole right here, and a big dipole on this side. So my picture might not be the greatest, but these are dipoles with the positive. They're all positive, negative, like positive on the left, negative on the right, and then these dipoles are a little bit longer because they're closer to the edges and they're more polarized. And the vector P in each case is like this. So this is long. These are long, and this one's small. Okay. Yay, okay, the end.